Polymers. What is polymer? A polymer is a long chain molecule formed from the combination of many repeating basic units. The basic units of the polymer is a monomer. The reaction of monomers to form polymers is called a polymerization reaction. Polymers can be classified into several groups based on their sources, the method of polymer production, and the characteristics of the resulting polymers. Sources of polymer. Polymers consist of natural polymers and synthetic polymers. Natural polymers are those formed naturally and can be obtained from the surrounding environment. Examples include starch, protein, and cotton. Synthetic polymers are man-made and produced through chemical reaction in laboratories and factories. Nylon, polyethylene, and polyvinyl chloride (PVC) are examples of synthetic polymers commonly produced in the industrial sector. Type of polymers. We have three types of polymers, which is thermoplastic polymers, thermosetting polymers, and elastomer polymers. Firstly, thermoplastic polymers. Polymers that can be repeatedly remolded upon heating and can be recycled. When heat, the thermoplastic polymers melt and solidify when they are cooled. Example, polythene, polyvinyl chloride PVC, and nylon. Next, thermosetting polymers. Thermosetting polymers cannot be remolded after heating. Thermosetting polymers normally disintegrate or burn upon heating and cannot be recycled. Example, melamine and bakelite. Lastly, elastomer polymers. Elastomer polymer can be stretched and can return to their original shape when released, possess high elasticity properties. Example, polyurethane and styrene butadiene rubber (SBR). Polymerization reaction. Polymerization reaction can be divided into two types, which is addition polymerization and condensation polymerization. Addition polymerization occurs when monomers that have double covalent bonds between two carbon atoms, C double bond C, react with one another. Addition polymerization reaction, alkane molecules link together to form a long chain of molecules called polymer, while smaller alkane molecules are basic units called monomers. Polythene is also known as polythene or polyethylene. Example of polythene is plastic bottle, and here the example of addition polymerization reaction to produce polythene. Condensation polymerization. Condensation polymerization involve at least two different monomers, consists of two functional groups that will take a part in the polymerization reaction. The product of condensation polymerization is the polymer and another byproduct such as water or HCl molecule. Condensation polymerization reaction to produce styrene, a type of polyester, and nylon, a type of polyamide. Polymers and environment. Back to environment, polymers are durable and take a lot of time to disintegrate. Many of sea creatures die because of pollutions. Landfills are filled with non-biodegradable plastic bags. We have three ways to help the environment. Firstly, recycling. Second, additives are added to enable plastic and decompose naturally by bacteria. And third, decompose using light, photodegradable.
Rubber trees, or the scientific name Hevea brasiliensis, were brought to Malaysia in 1877. It has continued to be developed as an important community in our country until the present day. Malaysia is known as the major exports for rubber gloves, condom, and catheters. Latex is a white fluid obtained from the rubber tree when the tree bark is tapped. Natural rubber that is found in latex is a natural polymer that is known as polyisoprene. This is the structure of polyisoprene. Monomer for polyisoprene is isoprene, or with IUPAC name 2-methyl-butone-3-diene. The protein membrane of rubber particles is negatively charged on the outer surface. This causes particles to repel each other, preventing coagulation. Characteristic of natural rubber. Characteristics of natural rubber are depending on rubber polymers that are natural elastomic polymers. The presence of double bond in the rubber polymer structure affects resistance of natural rubber towards oxidation by air. As we can see, here are the characteristics of natural rubber.
Coagulation of latex. Latex is collected in liquid form for processing, or it can be left to coagulate and to be collected a day after it was tapped. The collection of latex in liquid form should be done quickly because once exposed to the air, for a few hours the latex will start to coagulate and turn into solid. Coagulation process of latex. Firstly, the negatively charged protein membrane causes rubber particles to repel from each other. Second, hydrogen ions from acid neutralize the negatively charged protein membrane. Third, rubber particles collide with one another that causes protein membrane to break. Fourth, rubber polymers combine with one another that causes latex to coagulate. Acid can coagulate the latex by neutralizing the negatively charged protein membrane. Coagulation can take place by adding weak acid into the latex, or it can occur naturally by leaving the latex exposed to the air. Bacteria in the air enter the latex and secrete lactic acid, which eventually causes latex to coagulate. Latex coagulation prevention. Latex is also needed in liquid form to produce specific products such as gloves and rubber tubes. Alkaline solution such as ammonia is added into latex to ensure that coagulation does not take place. Alkaline solution consists of hydroxide ion that can neutralize the acid produced by the bacteria. The protein membrane of rubber particles remains negatively charged, and rubber particles will continue to repel when they draw near one another.
Now let's talk about vulcanization of rubber. As we know, natural rubber is soft, sticky, and has less tensile strength. So by doing vulcanization process, we can produce rubber with more elastic with better quality through the productions of cross-link between polymer chains. During the vulcanization process, the double bond between the carbons found in a rubber molecule will react with sulfur or other substance to produce sulfur crosslink. These are the alternative vulcanization method. Vulcanization by using sulfur is the main method used to produce vulcanized rubber from natural rubber. Nonetheless, this vulcanization method cannot be used for certain type of rubber, particularly synthetic rubber which does not contain C-C double bond. Vulcanized rubber produced is free from sulfur and more environmental friendly. These are the alternative organizations that we know, which is parasite, irradiations, and metal oxide. Vulcanized rubber has different characteristics from unvulcanized rubber due to formation of crosslinks during vulcanization process. The formation of sulfur crosslinks reduce the double bonds between two carbon atoms in vulcanized rubber that make it harder to be oxidized. Strong sulfur crosslinks prevent the rubber polymer from sliding when it strengthens and can return to its original shape when released. Let's go through unvulcanized rubber first. That's how it looks in normal state before stretching, then during the stretching. But after we stretching it, it can no longer return to their original positions. Different from vulcanized rubber. As you can see, that vulcanized rubber can always return to their original positions. This is because they have strong sulfur crosslink between them. Difference between vulcanized and unvulcanized rubber. Elasticity for vulcanized rubber seems to be more elastic than unvulcanized rubber. Vulcanized rubber seems to be hard, meanwhile unvulcanized rubber seems to be soft. In terms of strength, vulcanized rubber has higher strength than unvulcanized rubber. Vulcanized rubber also have resistance to high heat and more resistance towards oxidation. Unlike unvulcanized rubber, it has less resistance to high heats and easier to be oxidized.
Synthetic rubber. Synthetic rubber is synthetic polymer that is elastic in nature or elastomer polymer. Most synthetic rubber is produced as byproducts by petroleum. For example, neoprene and silicone rubber. Characteristic of synthetic rubber: hard, elastic, heat insulator, resistant to chemicals, resistant to heat, and resistant to oxidation. Uses of synthetic rubber. With the unique characteristic found in synthetic rubber, various items can be manufactured, having the advantage of mass production capacity while not being reliant on the weather or diseases like rubber tree do, makes synthetic rubber the main choice for manufacturing industries. This is the examples of synthetic rubber and their uses. Use of rubber and the environment. Unsustainable use of rubber materials will lead to environmental pollution. Synthetic rubber particularly takes a very long time to decompose and make disposal difficult. Vehicle tires are among the products of synthetic rubbers that need to be disposed of in large quantities. Natural rubbers, on the other hand, take short time to decompose biologically. Nevertheless, the use of natural rubber is limited due to the natural properties of natural rubber that is less resistant to heat and chemical solvents.